Bees. Everyone is familiar with them, at least in passing, and if you know anything about bees, you know that they are very important in pollination. Pollination being spreading the pollen of one flower to another flower, etc., etc., help the plants reproduce, help the bees get nectar, everybody wins. But did you know that most bees specialize in one type of flower? Mainly, this is not true of absolutely everything, but the vast majority. So flowers use pollinators to spread their pollen around, get it going, sexually reproduce, make more plant babies. That's how pollination works. But when plants get pollinated, they don't really want the other pollen being spread to them because they can't use it. It's just like, we don't want this junk, get rid of it. This iris does not want the pollen of, marigold in it because it's useless. It doesn't want that. It wants other iris pollen. So what plants do is they will, quote unquote, manipulate the bees into only going to them and plants of their species. Let's use Snapdragons as an example because they are a very interesting looking flower. They look like the dragon heads. They have that mouth that opens to get inside the flower. So the nectar and the pollen of the snapdragon are deep inside that little tunnel there, but in order to get to the nectar, the bee has to go deep inside the flower, like push past that mouth entrance in order to get to the nectar, and in doing so, it will pick up all the pollen that is deep on the inside. And this is kind of a lot of work to figure out. So the bees, they spend a lot of time going around these snapdragons, figuring out how to get in. Once they figure it out, they're like, oh, perfect, great, we love this. But snapdragons aren't the only flower to have a very complicated mechanism of getting in. This is kind of just one of the ones that's the most obvious. Lots of them are a lot smaller, and bees have to use like their tongue to get in and not their whole body. It's a process. So lots of flowers have very complicated mechanisms of like actually getting to the nectar. So once a bee figures out like, hey, I know how to get in here, perfect, I'm not gonna waste my time and energy on figuring out how to get into a bunch of different flowers. I'm just gonna keep going to these snapdragons because I already know how to get in here. So the bee, it figures out the mechanism of getting nectar from like one flower. They're fine. They just go and keep visiting those flowers, profit. And the flowers, they're only giving and receiving pollen to flowers of their own type. Like snapdragons are only getting snapdragon flowers because the bees that have figured out the snapdragon mechanism aren't going to other plants. Same thing with like irises. I don't know if the mechanism of getting into irises, but the bee figures out the iris mechanism and is like, sweet, I know how to do this, and then they only go to other irises so they don't have to keep figuring out how to get into a bunch of different flowers. So the bee profits by getting nectar and pollen and figuring out how to do it the most efficient way. The flower profits by getting efficiently pollinated without having to deal with junk pollen from other species and without the risk of their own pollen getting lost and being essentially useless because it got deposited onto the wrong species of flower. Also, this isn't like be-all, end-all, pun not intended. Like, obviously you can see bees going to different types of flowers if there's a bunch of different ones available in the same area. Some flowers have easier mechanisms than other ones. This isn't like a set-in-stone thing. But it is a very interesting evolutionary mechanism for both the bees and the flowers, and it also shows how intelligent bees really are, because they can figure out these pretty complicated mechanisms that these plants use to kind of not protect, but like most efficiently hide their nectar. And another interesting thing about lots of bees, particularly bumble and honeybees, is that they exhibit like visual learning. So if they see, like, people have actually run experiments, if you have an isolated population of bees, like there's a clear barrier, and then you have a population of bees that know how to pollinate a thing, the bees that are pollinating, they'll go to these different flowers, pollinate, whatever. The bees that are stuck behind a barrier are just stuck watching them, so they're not actually doing the pollination, they can just see what the other bees are doing. But when the watching bees are put into a environment with the same flowers, they can very easily figure out how to get the nectar the most efficiently. Like the bees that were not watching, that were just released and were like, here, go figure it out, they took it quite a bit longer to figure out the nectar mechanisms than the bees that were watching. So the bees that were watching the other ones noticed how the pollinating bees got the nectar, and when they were released there, they took a much quicker time to be able to figure out how to get the nectar. So they exhibit visual learning, which also is just very fascinating.